Hello Math 1040 and 1045 students. I wanted to record a quick video to go over the first part of the tuberculosis data project in case you have any questions. The first part of this project will have you select 10 countries from the World Health Organization database. If you click on the link listed for part A, it will lead you to this page that has a list of countries as represented by their flags. It asks you to select 10 of them using a sampling method. I will also recommend that you do it using a simple random sample. As we showed in class, we can do that in GeoGebra by typing in random between from 1 up to, in this case, 194. I choose 194 because there are 194 countries listed on that page. I get a number of 65, which would tell me to go back to that page and scroll down until I find the 65th country. I recommend to do that when you select the 10 countries. However, either way you do it, make sure for part A you describe your sampling method in detail and state the name of your sampling method you used, as well as list the 10 countries. For part B and C, you are then going to go to the tuberculosis database for those countries, also listed with the World Health Organization. The first part, for B, will have you look at a single country, and you can choose which one you want to do for this one. For example, if I chose the country of Qatar from my list of 10, it will ask me to go down and look at this side-by-side bar graph on the right side for incidents notified cases by age group and sex in 2019. It will then have you look at how many individuals we have for females and males and identify the category that has the largest number of cases. So for example, for females and males for Qatar, I actually see that the 25 to 34 age group has the longest bar for each of those. It will then have you find the relative frequency for each. I can look at the 25 to 34 age group for females and notice that it has a length of about 80 individuals, but that would be the frequency. The relative frequency would be 80 out of how many female individuals are in this table. I'm not going to count them right now, but as a judgment call, maybe if I come up with the fact that there's maybe 210 individuals that are female, then I would say the relative frequency would be 80 out of 210. Or about 0.38. You will do this for both the male and female individuals. And then it says, for the second part of B, what happens if you have 5,000 people? If you have 5,000 people in those gender groups, how many would you expect to be within that age group? Well, if I have 5,000 female individuals and I know 38% of them are within the ages of 25 to 34, then if I multiply 5,000 by 0.38, then I'd say that about 1,900 or 1,900 females of 5,000 are in the age group of 25 to 34. You would do that for both females and males for your country, and make sure to describe your process and the values you got for part B. For part C, you will then look at all 10 countries you had listed from Part A, and you will find two numbers from the tuberculosis profile. The first number will be near the top of the page, estimates of TB burden. You will look at the total TB incidence and record the rate per 100,000 population. You will then scroll down near the bottom of the page, and under the category of treatment success rate and cohort size, you will find the new and relapse cases registered in usually 2018, but it may be listed as a different year. If I do that for my country of Qatar that I did earlier, at the top, under the category of estimates of TB burden 2019, I see total TB incidence, and I will report the rate of 100,000 population. So then that means for Qatar, I'm going to report a number of 35. That will be my total TB incidence per 100,000. I will also then scroll down to the bottom of the page and find the category of treatment success rate and cohort size, and look at the subcategory new and relapse cases registered in 2018. This percentage will be the second number that I report for Qatar. You will report these two numbers for all 10 countries in your sample. Lastly, for Part D, this will have you do a hypothesis test. According to Part D, the global threshold for successful treatment of tuberculosis is 85%. What we are going to do is test the first member of WHO, or the first country we had listed in our sample, and test that against 85% to see if it's significantly different. To do so, we will use the Rossmann Chance applet that you hopefully remember from class. We have a sample of size 100 with a p of 0.85, and we will complete 50 trials of this. So, for example, if Qatar was my first country, the success rate was 71% that I still have highlighted there. That's the number I'm going to check against the 85% in the hypothesis test. To do so, I will open up the Rossmann Chance applet as linked in the Part D. The probability of heads, I will change to 0.85, the value listed in our hypothesis. We will do a sample size of 100. That is our N. And then we are going to be doing 50 samples or 50 trials of this. I will also unclick the show animation to make this go faster, and I'll also check the proportion of successes so I can compare more adequately to the 71%, 0.71, that I want to look at and see how many values I get that are extreme as that. Furthermore, because we are doing a not equal to for our hypothesis test, I will also change this into a two-sided test for the options. Once I have all those settings in place, I can draw my samples. In my specific case, the value of Qatar's tuberculosis rate of 71% is rather rare, at least when considering the 85% for the rest of the world. I found that 0 of the simulated samples resulted in a value as extreme as Qatar's value of either 0.71 or its equivalent on the other side. If I report that as my p-value, I would then say that because that p-value is less than whatever alpha level I chose, maybe 0.05 or 0.01, I will say that I will reject the null hypothesis that claims that the proportion is about the same as the rest of the world, and instead claim that the alternative, the proportion for that country, is different than the rest of the world. If I got a p-value was too high, was higher than alpha, I would instead claim the opposite and say that I failed to reject the null hypothesis, that I do not have enough evidence to claim that my country is any different than the rest of the world in terms of successful treatment of tuberculosis. That is what you're going to do for this project. Those are the following steps. Just make sure that you talk about all of the steps that you do, show your work for any instances that work is necessary, and for parts B and D, take pictures of the different graphs. For B, take a picture of the side-by-side bar graph from the tuberculosis page, and from D, take a picture of the dot plot created by the Rossmann Chance applet. Put all this information into a document created hopefully with either Word or Google Docs, and upload the file as a PDF. As a last note, if you do not know how to upload a file as a PDF, if you are working in Word, you will go up to File. You should see an option for Save as PDF. If you do not see that, you can go to Save As, and when you select a folder, you can change the option to be a Word document or a PDF. That about does it. Hopefully that answers any questions you have for part 1. If you do have any other questions, feel free to reach out to me. Otherwise, have a great rest of your day.